Hey everyone, I'm doing an audio video of an article on brain health and creatine and exploring the connection. Just for those of you who prefer to see and or hear things instead of reading. Your brain's the command center for the rest of your body. If you lose the ability to use your left arm, you'd still survive, but you can't afford to compromise the function of your brain or neurological system. So it makes good sense that you can do everything to support optimal functioning of your neuronal cells. If you go to my blog article of the same name, there's going to be a list of articles that I've written about how you can do different things to support your brain function. And I would urge you to read that, because the more you know, the more you can help yourself. But I want to keep it really simple in this article. And I always want to emphasize this, that you need exercise, nutrition, and recovery protocols to protect your brain and your neurological system, and really any system in your body. And make no mistake either that those three particular interventions matter, and they all matter equally. But today I'm going to be exploring a substance known as creatine, and it's a derivative of amino acids that support your brain health and function. So what is creatine? Creatine is a substance that's made from methionine, arginine, and glycine. That's kind of boring for most people, but I thought I'd put it there. These amino acids are readily found in animal protein sources, and about half your daily need comes from these food sources. But be sure to learn more about amino acids if you can, and in this article on the website, I have a breakdown of what amino acids are, where you get them, and why they're important. But believe it or not, your body also makes creatine. It makes it in your liver, kidneys, pancreas, and testicles. And this is all good stuff, but you might be asking why creatine is important. So creatine is like an ingredient that helps your cells make energy. And so that you have energy to do things. Creatine enters your cells, and they work with something called mitochondria, and they're basically little generators that make energy. They make something, specifically the mitochondria, known as ATP, adenosine triphosphate. You can learn more about that below in the same article. I have a link there as well. So ATP is a compound that gives our cells energy to do things, and it's made of a few items: adenine, a ribose sugar, and 3 phosphates, hence ATP. As soon as your body uses ATP for energy, it loses a little phosphate and it turns to ADP, adenosine diphosphate, and it's missing that little phosphate group. You can't get direct energy from ADP. Inside the mitochondria, ADP connects with a phosphate to make ATP. This ATP then moves out of the mitochondria and goes where it's needed. Good stuff. However, it's a very, very slow process. And there are many times when you need energy and you need it fast. And that's where creatine can help you. Creatine has the ability to pop into mitochondria and grab one of those phosphates that it likes to use. And it acts like a little dump truck, creatine, and it quickly carries that phosphate to other spots in your cell that need energy, high energy. Mitochondria can't make ATP fast enough, though, under very stressful situations. You only get about 1 second of ATP from mitochondria. I thought that was pretty cool. But creatine can grab that phosphate, and they can move it to sites of your cells that need it, and they can do it really, really fast. And that's why creatine is going to be very helpful in this discussion. In fact, when creatine carries phosphate to where it's used, you get about 7-ish seconds worth of energy production. That's a lot better than 1 second. And I was really curious about how creatine can help the brain specifically. That's going to be the focus of this article. Initially, I could understand how muscles needed creatine and ATP, and it was well covered, because you can visualize sprinting or lifting really heavy weights, and then you could understand, okay, creatine can be used to produce energy there. That makes sense. But I had a lot of trouble trying to figure out how the brain would experience quote unquote stress like muscles. I couldn't really intuit that. But there are a lot of situations, once you realize, that make a lot of sense. And it really makes a lot of sense when you understand how much energy the brain uses. Just check this out. So you might be aware, or unaware rather, that the brain is about 2% of your total body weight, but it consumes 20% of the total energy that you make every day. That's a lot. And up to 80% of the ATP that the brain makes, I think I forgot to mention that it actually makes its own, hint, hint, it's important, is used for neuronal firing. So where does creatine come to the rescue in the brain? Well, one that's really common with a lot of my clients, and certainly everyone's experienced this, is sleep deprivation at some point, i.e. not getting a full 8 hours sleep a night. And that can come from stress. It can come from poor sleep habits, for sure. And also neuronal diseases and in certain incidences like TBI, you could imagine hitting your head really hard from an accident or from sports. But even mental health conditions like depression and anxiety can really, really use a lot of energy. So we're starting to see how creatine could help here. They all drive increased creatine phosphate production, of course. And I think all of us have experienced some or all of these things to varying degrees in the course of our life, especially sleep and anxiety. We've all experienced that. And knowing that creatine can be helpful, how much might the brain require under stress? The bulk of creatine gets consumed in skeletal tissue. And part of this might be due to muscles' lack of internal creatine production. That makes sense. If it can't make it, then it's got to get it out of the blood, unlike the brain. And that muscle has a lot of creatine transporters. So they're basically little like doorways on the cell, and they allow creatine from the blood to be pulled in. So they pull it in and they drive it into the muscle. And that's largely, it's done only by genes that produce these transporters, and they're called SLC6A8 genes. Now, the brain has its own creatine producing factory, quote unquote, which can limit how much creatine gets from the blood into the brain. Because if you're making a lot in the brain, there's really not a requirement. You might think that anyways, but not necessarily. It's possible that when the brain comes under stress, it's not just possible, it does happen, that it begins accepting creatine from the blood. And this is where food and supplementation of creatine can help. Now, on the article that I have multiple examples of natural sources of creatine, and I really want to emphasize that it should be coming from food first. So think pork, salmon, beef, tuna, cod, herring, all great sources of creatine. It's food first, always. So when I was having a look at how creatine might help, I did a deep dive on more recent studies that looked at creatine and how it may help the brain, and I came across 11 different studies, and they were all insightful and helpful, but they didn't really have the same study designs, meaning they had some groups of people in their experiments that were healthy, others were not healthy. Some got low doses of creatine and others got really high doses of creatine. So it was hard to make a very general specific, or rather a specific conclusion, but on average, blood levels or brain levels did increase by about 10%. So that's insightful, I thought. But there's a particular study that I looked at where the researchers took a group of healthy subjects, about 15 females, I think, and then they exposed them to sleep deprivation over 24 hours. And then they introduced 0.35 grams of creatine per kilogram of body weight. They randomly assigned half of that group to creatine one night and then the other half to a placebo. And then a few days later, to give them some rest, they switched the design across, where the people that originally got the placebo ended up getting creatine and vice versa. And it was actually really interesting. I was curious what or how creatine would affect cognitive function and your ability to perform some basic tasks. And it was very clever what they found and very helpful. Um, Effectively, when they took that much creatine that I outlined earlier, they ended up increasing the brain creatine, so that's helpful. But they also experienced reduced fatigue. Their short-term memory tasks improved. Their reaction speed improved. And those particular effects lasted up to 9 hours. Impressive. So then the next question might be, well, that's all well and good, but like how much creatine should I take if I'm experiencing sleep problems or sleep issues or general stress? There are a few different options. There's one recommendation to do 20 grams of creatine per day. Another is 0.3 grams per kilogram of body weight per day for about a week for both of those. And then there was another one that was 4 grams a day for several months. So basically all of those options got your creatine levels up in your blood and up in your brain. But there's also another strategy that I thought was clever, and I liked it because it was based on body weight. It's called relative dosing. That's a fancy way of saying that. And basically, you do 0.1 to 0.14 grams of creatine per kilogram of body weight. I think I like that the most because it's specific. And funny about that particular relative dosing strategy, it's also good for improving your bone density, which is another topic, but I thought I'd throw that in. So, I mean, there you have it. You learned a little bit about what creatine is, how it works, why it's important, and how much to take. And remember, supporting your health happens when you embrace exercise, nutrition, and recovery protocols together. I cannot emphasize that enough. I always want you to remember that all three of those are necessary to improve your health and your performance. Keep it in mind. If you have any questions, reach out to me. I'm easily found on McIsaacHealth.com. Chat to you soon.